marks. Now come to DC circuits. We have network terminology. We need to study the network terminology. Second one, network elements. Third one, basic components and definitions. Current, I means current. V, voltage. P, power. E, energy. And Ohm's law. Third topic, basic concepts and definitions. And definitions we need to study. The first one is network terminology. Network terminology. Second one is network elements. Third one is basic concepts and definitions. So what are the definitions we need to study? Current, voltage, power, energy, and Ohm's law. And Ohm's law. Third topic. Totally how many topics we have? 8 topics. DC circuits only, not AC circuits. Still we need to complete AC circuits to complete unit 1. So today fourth topic, basic components of electrical circuits. We can call it as components, elements, and parameters. The fan we will analyze in inductive load. Bulb, pure resistive load. So I need the elements R, L, C. We have to analyze in this way. For example, I want to draw the circuit diagram for this room. Then I will analyze the circuits. Bulb as a resistive load, fan as inductive load. Like that I am going to analyze. So I need the knowledge of resistance, inductance, capacitance. In resistance, inductance, capacitance. So the fourth topic is basic components of electrical circuits. If we ask you the question, what are the parameters of in electrical circuits? The answer is resistance, inductance, capacitance. What are the basic components? Resistance, inductance, capacitance. What are the basic elements? Resistance, inductance, capacitance. This is the answer given to the question. So we need to study resistance. Again, I have divided the fourth one into 4 topics. Resistance, inductance, capacitance. What we have to study in first part 1? Definition, symbol, units, abbreviation related to resistance, inductance, capacitance. Related to I have divided into 4 parts. I want to study resistance, inductance completely. Resistance, inductance, capacitance completely I want to study. So I have divided into first part. What we have to study? Definition, symbol, units, abbreviation. I need to study. I want to complete total knowledge of resistance, inductance, capacitance. I want to complete total knowledge. Next one, second one, resistance, inductance, capacitance. Again, I want to complete the remaining topics. Factors. I need to know about the factors. On what factors does resistance, inductance, capacitance depends? Yes, already have studied in intermediate. The resistance depends upon R is equal to rho into L by A. R is equal to rho into L by A. So resistance depends upon the length of the conductor. Resistance depends upon the area of the conductor. Area of the already have studied in intermediate. So why I want to study this one? We'll later we'll study. Why we have to go? First, you know the topics. What we need to study. What we need topics. Clear? Right. Next one, basic analysis of resistance, inductance, capacitance. What is the basic analysis? I want to go into mathematical form. I need the formulas related to resistance, related to inductance, related to capacitance. I need basic analysis. Basic analysis is in mathematical form. I need the formulas to analyze the circuits. So numerical is very important for me to analyze the circuit compared to theory part. Numerical is very easy to understand the concept. So I need basic analysis. That is called next third topic. The fourth topic is resistive networks, inductive networks, capacitive networks. What is a network? We have 2 types of networks called series and parallel. Resistors can be connected in series. Resistors can be connected in parallel. In the same way, inductive loads. Inductor can be connected in parallel. Inductor connected in series. Capacitance in series, capacitance in parallel. Already you have studied in intermediate about the resistors in series, resistors in parallel. This is the fourth topic. Now fifth topic is equivalent resistance. The fifth topic is part 5. The fourth topic, I have divided into 5 parts. I have divided into 5 parts. What is the first part? Definition, symbol, unit, abbreviation. Part 2, factors. Factors. It depends upon the factors. Next, third one, basic analysis in mathematical formulas. I need the mathematical formulas to analyze the circuits. To analyze the circuits. The fourth one, networks. How many types of networks we have? 2 types, series, parallel. How many types of networks we have? Series, parallel. Resistors in series, resistors in parallel. Inductors in series, inductors in parallel. Capacitor in series, capacitor in parallel. Like that. The last topic, last one is equivalent resistance. The last one is equivalent resistance. Okay. Be silence. The last one. Be silence. Right. So that we will complete fourth part, fourth topic. Fourth topic will be completed. We need to study about the resistance, inductance, capacitance, completely knowledge. And you should know, because whenever you see the circuit diagrams called electrical circuit diagrams, will go the words resistance, inductor, capacitor always present in the circuit diagram. Always present in the circuit diagram. That's why I need to know the knowledge of resistance, inductance, capacitors. That's why you should know the knowledge of resistance, inductance, capacitance knowledge. The next one, fifth one, KCL and KVL. Again, we have studied in intermediate, but even though we will explain that one very clearly, how the KCL, KVL are presented in the network. Next, mesh analysis problems, nodal analysis problem, and superposition theorem problems. So that these 8 topics will completed DC circuits. So we have completed DC circuits. Clear? These are the 8 topics. Right? Once again, I want to discuss the latecomers who came late. So the subject is basic electrical electronics engineering. For latecomers, again I want to repeat it within 2 to 3 minutes. The subject of this one is basic electrical electronics. Again, this is divided into 2 parts. Part A, part B. Part A will study about the electrical. Part B will study about the electronics. The name given for part A is basic electrical engineering. Part B, basic electronics engineering. The latecomers, please listen it very carefully. Right. Again, part A is divided into 3 units. 3 units. Unit 1, Unit 2, Unit 3. Unit 1, DC and AC circuits. Unit 1, DC and AC circuits. Unit 2, meshes and measuring instruments. Meshes and measuring instruments. Unit 3, okay, energy resources, comma, electricity bill and safety measures. Safety measures. These are the 3 units. Comes under electrical. And again, we'll go for part B later. First, we'll complete the electrical part. First, we'll complete unit 1, DC circuit and AC circuits. DC circuits and AC circuits. First, today we'll complete DC circuits. Today we'll complete the DC circuits, direct current circuits. AC circuit means alternating current circuits. Alternating current circuits. DC circuits, we have 8 topics. 8 topics we need to complete total with problems. Totally we have to complete 8 topics. The first one is network terminology. network terminology, network elements, network element, concepts and definitions, concepts and definitions. What are the concepts and definitions? Current, voltage, power, energy, Ohm's law. We need to study. We need to study. Fourth one, we should know about the resistance, inductance, versus complete knowledge. Complete knowledge we should resistance, inductance, capacitance. Again, we have divided the fourth topic into 5 parts. We have divided the fourth topic into 5 parts. So what we have to study? Yes, the first study we have to study about the definition, symbol, unit, abbreviation, about resistance, inductance, capacitance completely. Next one, part 2, factors. On what factor does resistance depends? On what factors inductance depends? On what factors capacitance depends? Part 3, basic analysis. Part 3, basic analysis, mathematical form. I need the formulas. If I get the formulas, it is very easy to analyze the circuits. It is very easy to analyze the circuits. I need the formula compared to theory. Compared to theory, we should have theory. I'm not saying that we should not have theory, but easy to analyze the circuits. Easy to analyze the circuits. We should have the formulas: resistance, inductance, capacitance. The next one is networks. We have 2 types of networks: series and parallel. Series and parallel. If resistors are connected in series, what is the conclusion we get? What are the results we get? If resistors are connected in parallel, what are the results we get? What is the conclusion given by the resistors in parallel? What are the results? Same, the same thing, inductors in series, inductors in.
Answer of your question. In series, we are combine the connectors or resistors, the voltage is becomes changed.
Yes.
But
See,
again,
still we have not started the subject. Okay. This is only the topics we have discussed, right? Still they have not started it all. If we started, then we can. Why it is connected in parallel? Why it is connected in? So that's why I'm saying no. When resistors are connected in series, we get the results. We get the. We'll discuss the results. How many results we got it? Clear? Got it? Only topics we have discussed. We are not entered into the topics. Clear? Right. Now, resistance in series, resistance in parallel, inductance in series, inductance in parallel, inductance in like that. Last one, equivalent resistance. Last one is equivalent resistance. Now I will give you a circuit. Now I will give you a circuit. In that circuit, in that circuit, some are connected in series, some are connected in parallel. I will give you a circuit. One problem. It is for 4 marks question. In that circuit, some resistors are connected in series, some resistors are connected in parallel, 5 resistors given. We have to convert into single resistance. 5 resistors are connected in series, maybe parallel. We don't know. We have to check it. We have to check the diagram and convert into series. We have some formula. Parallel, apply the formula. Will finally the 5 resistors should be converted into single resistance. So finally, what is the conclusion? In the problem, how many resistors are there? 5 resistors. It may be connected in series, it may be connected in parallel. The final conclusion, we have to convert into single resistors. We are converted into single resistance by the knowledge of series and parallel knowledge. By knowledge of series and parallel. We have to find out which is series, apply the formula. Which is parallel, apply the formula. Then convert into single resistors. Then convert into, that is called equivalent resistance for the given circuit. For the given circuit. Clear? Equivalent resistance. Once again, the problem is given. In that problem, it is called a circuit problem. In that problem, we have 5 resistance. It may be connected in series, it may be connected in parallel. We need to find out which is series, apply the formula. Which is parallel, apply the formula. And convert into single resistance. Convert into single, that is called equivalent resistance. That is, so totally 4th topic is completed. 4th topic is completed. Now 5th topic, KCL and KVL. KCL and KVL already have studied in intermediate, even though we have to do the problems, because to understand mesh and nodal analysis, we need the knowledge of KCL KVL. We should have the knowledge of KCL KVL, mesh analysis and nodal analysis. The last one is superposition theorem. Superposition theorem. So in this way we have completed today DC circuits. Okay, then we'll go for AC circuits. Okay, this is called unit 1. So all of you clear? First we should know the topics, then knowledge. First, we should know the topics, what we have to study first. So, how to get the marks? Knowledge plus marks, both should we have. Okay, if you complete this one, definitely you will get 11 marks. The final exam 70 marks question. From unit 1, you will get 11 marks. These are there is no other topics. These are the topics you have to study. It's a confirm you have to study these topics only as per syllabus. As per syllabus, you have to study these topics. Clear all of you? Right. Next one. First topic. Go for first topic. PPT. Right. Okay. So these are the terms we have to read first. Understand the concept. In network terminology, I will give one circuit to you. You take any kind of circuits. It's complex circuit, simple circuit, any kind of electrical circuits. In that electrical circuits, resistance are present, voltage is present, inductance are present, capacitance are present. Then how to analyze the circuits? All are present. But we need to know what is circuit, what is electric network, what is node, what is junction, what is branch, what is loop, what is mesh, what is circuit parameter. Circuit parameter. Okay, you can go down loop after loop. So loop, mesh, next one, circuit parameters. I can go for first one. So what are the network terminology? What are the terms we have? What are the terms we have in first topic, network terminology? The first one is circuit, electrical network, node, junction, branch, loop, mesh, circuit parameter. These are the terms you have to know first topic, network terminology. Otherwise, you cannot do the problem. It's a confirm one, you cannot do the problem, you cannot analyze the circuits. You cannot analyze the circuits. That's why this is a basic foundation. A network terminology is the basic foundation. You have to understand what is circuit, what is electrical network, what is branch, what is node, what is junction, what is circuit parameters. Everything you have to understand the terms very carefully. You have to listen. First, you have to know the network terminology. If you ask you the question, what are the networks, the basic terms? The answer is circuit, electric network, node, junction, branch, loop, mesh, circuit parameter. Circuit parameter. So these are the knowledge you should have about network terminology. About network terminology. So clear all of you? The first topic. What is the first topic? Network terminology. Totally unit 1. What is the name of the unit 1? DC circuits and AC circuits. What is DC circuit heading? Direct current circuit. AC circuits, alternating current circuit. Alternating current circuits. In DC circuit, how many topics we have? 8 topics we should read. Get the knowledge. First one, network terminology. First one, network. So what to study in the network terminology? This is the question mark. What to study? Yes, we have to study what is circuit, electric network. Okay, next one is node, junction, branch, loop, mesh, circuit parameter. We have to study. We have to understand the concept. We have to understand the concept. Clear? Right. Now, so how to get the knowledge? Yes, I will take a simple circuit diagram. I will take a, to understand these 8 terms, 8 words or 8 terms. What should I take? One simple electrical circuit diagram I have to take to get the knowledge. To get the knowledge. In that circuit diagram, I will take 2 voltages, 3 bulbs. So bulb should be converted into resistance. The bulb is made up of filament. It is a conductor. I will tell you what is conductor, everything later. First understand the concept. Okay, I will take one simple circuit. In that circuit, 2 batteries are connected, E1, E1, E2, and 3 bulbs. I won't draw the bulbs. Bulb is conductor. Conductor is having a resistance. Conductor is having a, right, that resistance you have to keep in your mind. Keep in your mind. I'm not drawing the bulb here. Bulb is made up of filament. It is a conductor. It is a conductor. That filament is having a resistance. The filament is having a resistance, confirm. You take any kind of conductor, we should have a resistance. Whether examples of conductors are silver, gold, copper. So many examples are there. I will tell you. Not worry. See, last we will discuss the questions. Okay, because I know how to. We are following one route. Okay, I will tell you that route also. Okay, not to worry. First we should say what is conductor, what is insulator. We'll discuss later whenever we get a. I know when to teach the conductor, when to teach insulator. First thing is we should know these 8 terms. First thing is we should know the 8 terms confirm. So to understand these 8 terms, I should go for circuit diagram. I should go for circuit diagram. So electrical circuit diagram is called as simple electrical circuit diagram. So what is the electrical circuit diagram? I have taken 2 batteries. The next page. Yes, this is the diagram. I have taken 2 batteries, E1, E2, left side E1, right side E2. Left side E1, right side E2. I have taken 2 batteries. I have taken 2 batteries, 3 bulbs. The bulb is made up of filament having a conductor. The conductor should have resistance. So instead of bulb, I am drawing the resistance. Instead of bulb, what I am drawing? Resistance R1, R2, R3. This is a simple circuit diagram. The simple circuit diagram consists of 2 batteries, E1, E2, and 3 bulbs. Bulb is replaced by resistor. Why it is replaced? Because bulb is made up of filament. Filament is nothing but a conductor. Conductor should have a resistance. So instead of bulb, have made into resistance. Have made into resistance. Why I am drawing this diagram? To understand the 8 terms. To understand the 8 terms. I want to clear it. The 8 terms with help of one diagram. With help of one diagram. So simple electrical circuit diagram. Simple electrical circuit diagram. Again I'm telling, I have taken myself 2 batteries, E1, E2 and 3 bulbs. The bulb is replaced by resistance R1, R2, R3. Is it clear? This is the diagram. Now I want to tell you the first question 1. The question 1 is how many elements are present in the given circuit? Question number 1. After drawing the diagram, my question is the first question. How many elements are present in the given circuit? Right, totally 5. Totally 5. E1 one element, E2 one element, R1 one element, R2 one element, R3 one element. Totally the answer is 5. Total answer is 5 elements. You take any kind of circuit, you have to tell the first question. Complex circuits, simple circuits, whatever the circuits, electrical circuits, the first question is how many elements are present in the circuit? Then the answer is 5. Depending upon the circuit diagrams. Depending upon the circuit diagram. Clear? Right. How many elements for the given circuit? 5. What are they? E1, E2, R1, R2, R3. Clear? Right. Question 1 is completed. Question 1 is completed. Now question 2. How many are active elements? How many are passive elements? Active is batteries. Active elements are examples are battery, which is given to the bulb to glow the bulb. Batteries are responsibility to glow the bulb. Who is the responsibility? Batteries are responsibility to glow the bulb. R1, R2, R3 should glow. So we should give power deliver. We should give power to the elements R1, R2, R3. Which are giving power to the elements? Which are giving to the power to the R1, R2, R3 bulbs? That is called active elements. That is called active elements. So how many active elements are present in the circuit? 2. What are they? E1, E2. The examples of active elements are batteries, generators, RPS, regulator power supply, DC generator, AC generator, whatever it may be. We are giving supply to the bulbs. We are delivering power to the bulb. We are delivering power to the bulb to glow the bulb. To glow the bulb. So it is called active elements. So it is called a active elements. Next, the same question, second question. How many are passive elements? 3. R1, R2, R3. Not only resistance, inductance is a passive element, capacitance is also passive element, but here I have not mentioned. But in this diagram, I have not mentioned inductance, capacitance. I have not mentioned inductance, capacitance. What is the passive elements? It will take the power from the energy source called battery and do useful work. And do what is the useful work? It will glow. What is the useful work? It will glow. It will take power from batteries, active element. It will take from active element power. It will use it. Bulb will glow. Again, I will give power to the fan. Fan will rotate. It is useful work or not? Fan is rotating. It is a passive element. Which is the passive element? Inductance. Fan is inductive load. Fan is a inductive load. We have to give power to the particular element to do useful work. To do useful work. This call or called which are you doing useful work? What are the useful? Bulb is a useful work. Fan is a useful work. TV is a useful work. Computer is a useful work. We all are doing useful works. In that, if you open it the computer, we have resistance, inductance, capacitance. If you open the fan, we will have inductance. You can see magnets, coil. If you open the bulb, we have a filament, resistance. So these are all called passive elements. What are the examples of passive elements? Resistance, inductance, capacitance. In this problem, we have not given inductance, capacitance. In this problem, we have not given only resistance. The answer is R1, R2, R3 is the answer. R1, R2, R3 are the answers. So second question is completed. Second question is what is the first question? How many elements are present in the given circuit? Fine, clear. Leave it. Second question, how many are active elements? How many are passive elements? Clear now? Now third one, node. How to find out the nodes for the given circuit? For the given circuit, how to find out? Yes, the node minimum two elements joined at a particular point. Minimum two elements. More than, if it is more than two, is fine. But we have to start with two. We have to start with two minimum. Can I say R1 and E1? Can I join? Can I join R1 and E1? R1 E1. R1 E1. Can I say A is the node? Minimum two elements joined at a particular point. Minimum two elements should be joined at a particular point is called a node. Is called a node. Can I say A is the node? R1, R2, R3. Can I say B is the node? Minimum two. Start with two. Minimum two. More than two is okay. It is a node. It is a node. B is, can I say B is the node? Yes, B is the node. Minimum two we have to start. More than two, okay, it's a node. Right. Can I say next one? R3, E2. Can I see is a node? C is a node. C is a node. Next one. Can I say E1, R2, E2 joined at particular point? Can I say D is a node? Yes, D is a node. So how many nodes are present for the given circuit? 4. How many elements are present for the given circuit? 4. Once again, I want to explain this diagram. Those who not understand will be very clear for them. E1, two batteries. R1, it is a bulb which is having a resistance. Is another bulb. Is another bulb. 3 bulbs, 2 batteries. Now node. I am joining R1, E1. Yes, this is the node. Next one. 1, 2, 3 is the node. 1, 2 is the node. Yes. And this one sometimes E1, R2, E2. This is the node. I want to split it. These are all copper wires. If it is 0, wherever you see it is a 0. These all are 0. These two diagrams are same. This diagram indicates this one. These two diagrams are same. This is E1. This is R2. This is E2. Joined at particular point. Minimum 3 elements. Minimum 3 elements. For example, it is 0. Convert this diagram into this one. If you see anywhere, what is the value? 0, 0, 0, 0. If you see anywhere, this is 0. These two diagrams are same. These two diagrams are same diagram. Sometimes we will draw like that, sometimes we will draw like that. That is only the difference. Both are same. Both are same. So this is one node. This is 1, 2, 3, 0. Can you tell me what is the value of here? 0. Here, here, anywhere you see, the answer is 0. If I say 1, 1. If I say 2, 2. If I say 3, 3. It is a one node. Totally how many nodes now? 4 nodes. Give the names. So I have given the names. Give your wish. X, Y, Z. 1, 2, 3, 4. Otherwise, A, B, C. In this way, if you see any kind of circuit diagram, we have to find out the nodes. Not only this diagram, you take any kind of diagram. If I give second problem 2, one circuit diagram, find out the nodes. Problem 2, I'll give one diagram. You have to find out. This is problem 1. Clear? This is theory part. Node is clear all of you? Minimum 2 points joined at a particular point. Minimum 2. More than 2, okay, fine. But minimum 2. Start with 2. Start with. Clear all of you? Right. Node is completed. Node is completed. Now go for junction. Junction minimum 3 start. Start with more than 3. But start with. You tell me how many junctions are there? 2. One is 1, 2, 3. Yes, B only. 1, 2, 3. B only. Minimum 3. No 2. Minimum 3 joined at a particular point is called a junction. Minimum 3. Start with 3. More than 3 is okay, junction. This is called the other name for junction is principal node. Other junction is principal node. But if you see the textbooks, you never go for node. Always you will maintain junction. The name given is node. Node. If you ask particularly, tell me the real difference between node and junction, then you have to tell the real definition. Then you tell the real definition. But in textbook, you will say node only. You have to think junction. If in textbook is mentioned node means you have to think about the junction only. No node. If they ask the real definition, if they ask the real definition, then you have to say minimum 2, minimum 3. Minimum 2. If you see the textbook nodal analysis, what it means? Junction analysis. Nodal analysis means junction analysis in textbooks, as per textbooks. As per textbooks. So junction is completed. Sir, go for the next one. Junction is completed. Next one, anyone? Next one, branch. Next one is branch. Next one is branch. I can draw the diagram. See, after the completion of topic 1, I'm going to ask you the questions. You have to give the question, answer to the question. Telling now itself one. After the completion of topic 1, right? Now I'm talking about the branch. Which lies between two junction points is called a branch. Which lies between two junction points is called a branch. How many junctions are there for the given circuit? 2. 1. So we have given the names called A and B and D in the problem. In the problem, we have mentioned B and D, these two junctions, right? The first branch, I will tell you the how many branches for the given circuit. The answer is 3. The answer is 3. What is the definition of junction? What is the definition of junction? Which lies between two junction points. Which lies between two junction points. Right. Can I say this is B, this is D? Can I say which lies between two junction points? Can I say this one? Which lies between first junction, junction? It lies or not? Yes. What is there in this one? R1, E1. So the answer is R1 plus E1 makes you one branch. Makes you how many branches? 3 branches. How many branches? 3 branches. What is the first branch? R1 plus E1 is a branch. R1 plus E1 is a branch which lies between two junction points. Which lies between two junction points. Second branch. Can I say B to D? Which lies between two junction points? What is the answer? So R2 is the second branch. R2 is the second branch. The third branch. Which lies between two junction points? R3 plus E2. So R3 plus E2 is called third branch. This is the how to find out the branch for the given circuit. So how many branches? The answer is 3 branches. What is junction? What is branch? Which lies between two junction points. Which lies between two junction points. So which lies between is R1 plus E1 one branch, R2 second branch, R3 third. R3 plus E2 is the third branch. Third branch for the given circuit. Clear? So branch is completed. So branch is completed. Next one is mesh. Next one is mesh. Next one is mesh. Just closed circuit is called a mesh. Just closed circuit. How many closed circuits are there? One closed circuit. Closed circuit. Just closed circuits. By seeing the diagram, by seeing itself, we can say two closed circuits. Two is called a mesh. Is called a. How many meshes for the given circuit? Answer. Answer two. So mesh A B D A. What is answer? A B D A. This is one mesh. A B D A. One mesh. Next one. B C D B. B C D B. This one. B C D B. I have mentioned in this one. How many meshes? The answer is 2. Is the answer. Mesh is completed. Branch is completed. Node is completed. Junction is completed. Next one, loop. Next one is loop. Next one is loop. Right. Close circuits. Close one, loop. Loop one, loop two. In loop, we can remove any branch. And if it is if circuit is formed, no, then it is a closed circuit. We can remove. In mesh, we cannot remove. The condition of mesh is we should not remove a single element. What is the condition of mesh? We should not remove a single element. But for loop, we can remove and check that it is closed circuit or not. Yes, 1 and 2, two loops are completed. If I remove any branch, can I make third closed loop? If I remove any one branch, one element, which can I remove? R3. Can I remove R3? If I remove R3, can I get a closed circuit? Can I get a closed circuit? For loop, we can remove. For loop, we can remove and tell me the closed circuits. Tell me the closed circuit. So loop 1, loop 2. If you remove R2, can I get a closed circuit? Yes, this is third loop. This is the third loop. There is no other option. There is no other. How many loops for the given circuit? Answer 3. The answer is 3. For loop, we can remove the element. If it is a closed circuit, make it third one. Make it third loop. So this is called loops. For mesh, we should not remove. For mesh, we should not remove the element. Just how many closed circuits are formed? How many closed circuits are formed? This. So this is called a loop. Next, how many circuit parameters are there? Resistance, inductance, capacitance. Here only resistance. Here only. How many parameters are there? Only resistance. No inductance, no capacitance for the problem. For the problem. So that we have completed all the topics. So network terminology is completed. Network terminology is completed. We have two types of circuits. First topic is completed. Topic 1 is completed. Now I will tell you the circuit. I will tell you the what is circuit. Minimum one source, one battery, one bulb. It should be a closed path. It should be a closed path. So that current will flow, bulb will glow. Minimum one battery, one bulb. It should be a closed path so that current will flow, bulb will glow. Then it is called a circuit. Then it is called a circuit. It is a closed circuit. The name given is closed circuit. For example, if I remove, if I make a open, if I make a open, bulb is open. Now bulb is open. Then what is current I? Zero. Bulb does not go. Why? Because we have opened there is no closed circuit. It is called a open circuit. It is called a open circuit. We have two types of circuits. One is called a closed circuit, the other is called a open circuit. In open circuit, the bulb does not glow. The bulb does not glow. Why it does not glow? Current is zero. Current is zero. Here closed circuit, we have a current, then bulb will glow. So this is called circuit. This is called circuit. Then what is electric network? Circuit is completed. Okay. One source, one bulb, closed circuit, current flow, bulb will glow. It is a circuit. It is a. But what is electric network? Electric network, we have minimum. Here is minimum one source, one bulb. If more than one source, more than one bulb is called network. It's called a network. The example, last class, how many batteries we have taken? The last one, the previous one. How many bulbs? Three bulbs. One. This is called a network. This is called a more than one source, more than one bulb becomes a network. Becomes a network, electric network. Electric network. So that we have completed all the 8 terms related to network terminology. Related to network. Sir, first slide. Sir, slide 1. Slide 1. First one. Circuit. First one. Network terminology topic. Circuit. First one, sir. Top one. Top one. Right. Once you read it, I will ask you the questions. 1 minute time or 2 minutes time. So that I will ask you the questions. Network terminology. Then we will go for one problem. Then we will go for one. Next slide. Slide. Next slide. Right. Now I'll give you a problem. Find out the nodes, circuit elements. Write down the problem. Problem 1. In the circuit configuration of figure, problem 1. Problem 1. In the circuit configuration of figure, write down. In the circuit configuration of figure, obtain the number of first one circuit elements. First one circuit elements. Second one active and passive elements. Second one active and passive elements. Active and passive elements. Second one active and passive, passive, passive elements. Third one nodes. Nodes, nodes. Fourth one junction points. Junction points. Fifth one branches. Sixth one meshes. Sixth one meshes. Seventh one loops. I'll draw the diagram. I'll draw the diagram. After the drawing చేసిన తర్వాత అది చూపించండి చేసిన తర్వాత show me this diagram. R1 R1 R2 R3 R1 R2 R3 V1 this loop V1 R1 R2 R3 this mesh or loop. Next one second mesh R4 R5 R6 R8 V3 mesh 2 R4 R5 R6 R8 V3. Next last mesh already R7 V1 R9 R2. This is the given problem. Complete the question. అందరూ చేయండి. All should do. This is the question. Complete how many elements? Write down. Start it. First one. After drawing the diagram, go for the first one. Number of elements. How many elements? Number of elements? 12. How many number of elements? 12. In bracket, V1, V2, V3, R1 to R9. Close the bracket. First one. Number of elements is equal to 9. First one. Complete the diagram, please. I'm giving 30 seconds time to complete the diagram. 30 seconds time to complete the diagram. See, if you get a problems, please stop it. If you get a problems, okay, go for my style. మీరు చూడకండి ఇక షేరింగ్ చేసుకోకండి ప్రాబ్లమ్స్ అనేది చేయాలి యూ హ్యావ్ టు డూ ద ప్రాబ్లమ్స్ దెన్ యూ విల్ గెట్ ద నాలెడ్జ్ దిస్ ఈజ్ R5 R5 right. First one, number of elements is equal to 9, is equal to 9 in bracket V1 V2 V3 V1 comma okay, V2 double time it has been repeated, two times it is been repeated, it is V2, it is V2, double time it is been repeated, V1 V2 V3 V1 comma V2 comma V3 comma R1 to R9. Close the bracket. Close the bracket. This is first one. This is the first one. Under చేయండి. Check the elements. Just count the elements. Just count the elements. That's it. Answer is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 elements. Just count the elements. Right. Second one. Second one. Active elements is equal to 3. In bracket V1, V2, V3. Batteries to run the circuit. To run the circuit. Let's go for right. Number of L nodes, anyone? 10. Okay. Show me the diagram, sir. Show me the diagram. So I don't want to waste the time. R1 V1 makes the node. See this one diagram. R1 V1. How many nodes are there? 10. How many nodes are there? 10. We'll check it the 10 nodes. We'll check the 10 nodes. Can I R1 V1 can I join it? Minimum 2. Minimum 2. Give the name, your wish. You can give any kind of names. 1, 2, 3, 4, A, B, C, D, capital A, B, C, D, whatever it may be. Okay, you give the name. What is the name given here? A. Right. Next node. Can I say B is the node? How many elements are joined? 4. R1, R8, R2, V3. Can I say this is the node? Minimum 2 undal. Minimum 2. More than 2, not to worry. Minimum 2. You get more than 2, not to worry. It is a node. It is a node. Give the name. What is the name given here? B. Next one. Where we are given C? Can I say R5, R4 is a node? R4, R5. Third node. Give the name C. Give the name C. Is it clear, all of you? A, B, C, D. A, B, C. Next one. D. Where have I given the D? Here. R5, R6. Minimum 2. R5, R6. D. Give the name called D. Next, where E given? E. How many elements joined it at E? 1, 2, 3. Give the name called E. Give the name called E. Next, F. Where we have given the F? R5, V2. R5, V2. We have given the F as per my notes. Not to confuse. That's it. Next one. G. Next one is G. R9, V2. Can you make a join here? R9, V2. R9, V2. Can I make a node here? Yes. What is the name given? G. G. R9, V2. Minimum 2 elements. Minimum 2 elements. Next, H. R2, V3, R3, R9. Given the name called H. Minimum 2. Next, last one. R3, V1. What is the name given here? K. As per my notes. Now count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Where it is one more we have R4, R3 we missed. R4, V3. R4 we have missed the node. Totally 10. Give the name called. The last name is whatever it will be KJ. Whatever the name given. Not to worry about the name. నేమ్ గురించి బాధ లేదు ఇక్కడ. నాకు కావాల్సిన నోట్స్ మనం పెట్టుకున్న ఆ పేర్లు పెట్టుకుని మనం పెట్టుకున్నాం. క్యాపిటల్ ఏ, స్మాల్ ఏ, అదర్వైజ్ 1 2 3 4. Otherwise 1 2 3 4. Whatever it may be. How many nodes for the given circuit? 10 nodes. 10. Check it out. 30 seconds time. Complete check please. 30 seconds time. Discuss by yourself. Please discuss by yourself. If you don't understand, please discuss so that you get the knowledge. Don't sit idle. Don't sit idle. What is the name given instead of in my notes? It is not J, it is P I have given. I have given the name called P as per my notes. As per my notes, I have given the name called P. Not confused because I want to share the notes also. This is a practice session. తర్వాత మీకు సెండ్ చేస్తా నోట్స్, నాట్ టు వరీ. ఓకే, ప్రాక్టీస్ చేయాలి ఇక్కడ. యూ హ్యావ్ టు ప్రాక్టీస్. నెక్స్ట్ వన్ సార్, నెక్స్ట్ ఆన్సర్. గో ఫర్ ద ఆన్సర్. నెక్స్ట్ స్లైడ్. ఆన్సర్. Number of junction points. 3. Anyone answer? 3. What is junction? Minimum 3 elements. Minimum 3 elements. So what are the 3 elements here? The answer is B. 4 elements are joined. For B, how many elements are joined? 4. What is junction? Minimum 3. Yes, 4 are there. Satisfied or not? Satisfied. Minimum 3. Next one. Next one, E. Where is the E? How many elements are joined? 3. Minimum 3. Minimum. The next one is H. Where is the H? This is the H. Minimum 3. 1 is 4. E is 3. H is 3. So minimum 3 elements. Then only it becomes a junction. Then only it becomes a junction. So number of junctions are 3. B, E, H. Clear? This one. How many elements for B? How many elements joined at B? Check it out. How many elements are joined at B? B. B. 4. Can I call it a junction? Yes. What is the condition for junction? 3. Yeah. Clear? Right. For H, how many elements are joined? For H, 3. What are they? R2, R3, R9. Right. Next one. Third one. E. How many elements are joined at E? At E. How many elements? E. 3. What are they? R6, R8, R7. So I call it as a junction. I call it as a junction. Next one. Now branches. Now branches. How many? 5. How many elements? 5. What is the branch? First question number 1. Which lies between 2 junction points? Check only junctions. What are the junctions? B, E, H are the junctions. Which lies between 2 junction points is called a branch. Is called a branch. Right. The first one. The first one. Can I say this is the branch? B and H. B and H. Can I say this is the branch? Which lies between 2 junction points? Which lies between? So what are the elements joined? R1, V1, R3. So R1 plus V1 plus R3 makes a branch. Makes a branch. So I have given the name called, what is the name given here? R1, BAKH. What is the name given here? BAKH. The name given. BAKH. BAKH. What are the elements? R1, V1, R3. BAKH. This called. Here we have A. Here we have K. BAKH. BAKH. What are the elements present? R1 plus V1 plus R3. The last one. The last one. BAKH. The last one. BAKH. One branch. One branch. How many branches? 5. How many branches? 5. One completed. One completed. What is the answer? BAKH is equal to R1 plus V1 plus, this is one branch. Which lies between 2 junction points. Which lies between 2 junction points. Clear? Branch 1 is clear, all of you? Right. Second branch. Can I say this is the branch? B and H, middle. Which lies between? What is the element here? R2. Second branch is R2. What is the answer? BH. What is the answer? BH. BH. This is the, see, BH unda akkada? BH unda leda? Yes, BH is equal to R2. BH is equal to second branch out of 5. Out of 5. Which lies between two junction points. Which lies between two junction points. Next one. Third one. Can I say this is the branch? B and E are the junction points. B and E. B and E. Can I say this is the branch? This one. This is B and E is the branch. B and E are the junctions. This is the branch. This is the branch. So what are the elements present here? Elements present here? V3, R4, R5, R6. So answer is V3 plus R4 plus R5 plus R6. What is the name given here in this diagram? BF, BFCDE. The first one. Check it out. Third one. Please check it out. Third one. Please check it out. Third one. So once again, third branch. Once again, third branch. BE are the junctions. BE are the junctions. What is the junction? Which lies between two junction point is called a branch. Which lies between two junction point is called a branch. So this is called a branch. What are the elements present? V3, R4, R5, R6. The names are B, P, C, D, E. Third branch. Third branch. This is incomplete circuit. Can I say it is incomplete circuit? This is incomplete circuit. Still we have. This is incomplete circuit. You have to complete. How many branches required to complete the circuit? 2 branches required to complete the circuit. How many branches to complete the circuit? 2 branches required to complete the circuit. Till now we have only 3. Till now we have only 3. Still we have 2 to complete the circuit. To complete the circuit. Next one. Can I say BE is one branch? B and E. Which lies between two junction points? What is the answer? R8. R8. BE is the junction point which lies between two junction points. R8 is called branch. Fourth branch. Which branch? Fourth branch. The name is BE. The name is BE. Next one. The last one. H and E junctions. H and E junction. Can I say this is the branch? Which lies between two junction points? This one. This one. Here to here. What are the elements present? R7, V2, R9. R7, V2, R9 is called a branch. R7 plus V2 plus R9. So what is the name given here? E, F, G, H. So 5 branches. So the total circuit is completed. Total circuit is as per diagram. As per diagram. So in this way we have to find out the branches. In this way we have to find out the branches. Next problem onwards, I won't tell A, B, C, D, V1 plus V2 plus. Tell me the branch. This is the branch. Next class onwards, next session or whatever it may be, next problem, whatever it may be, don't mention the names. This is the branch you have to tell. This is the branch. This is the branch. This is the branch. Don't give any kind of names. Don't give any kind of names. To practice, I have given the names. To get practice, I have given the names. A, B, C, D, E. Confusion, totally confusion. You have to say that 5 branches are. Yes, this is one branch, this is one branch, this is one branch. Finished, completed. To practice, I have given the names. Clear all of you? So branches are completed. Branches are completed. Next one. Loops. First go for meshes. 1, 2, 3. 3 meshes. First is, we should not remove any element. We should not remove any element. How many closed circuits are there? 3. So 3 meshes. This is confirm. How many meshes are the given circuit? 3. You can write down the names later on. I'll give the notes. Don't waste the time. Clear? Right. Now come to loops. Right. First loops comes under mesh. 1, 2, 3 loops. After that, if you remove any one element, can you make a closed circuit? Yes. Which element will you take first one? R2. If I remove this element, this is a closed circuit. Fourth loop. Fourth loop. Fourth. Already 3 is present. This fourth one. If I remove the, if I keep this one same, if I remove another element, which is the closed circuit? R8. Fifth one. Fifth one. If I remove two elements, R1 and, can make a closed circuit? Two elements. Sixth one is remove two elements. Sixth one is remove two elements to form a closed circuit. To form a total how many circuits now? 6. First one is mesh. 3 meshes is equal to 3 loops. After that, which one you have removed? R2 to close circuit. Next one, which one you have removed? R8 to the fifth one. After that, sixth one, R, R8 and R both removed to form a closed circuit. You have to check. There is no seventh one. There is no seventh one. Only 6 loops are present for the given circuit. Only 6 loops are present for the given circuit. So that we have completed all the problem. Clear? Right. Now we'll go for KCL and KVL fifth topic. Once out of 8, first one is completed. Network terminology. Network, 8 terms we have completed and given 2 problems. One is on the board, one is practice. One is on the okay, board we have discussed the first one. Okay, after the one problem is practice session. So that network terminology is completed. Now we'll go for out of 8th one. I'm going for 5th one, KCL KVL. 5th one, KCL KVL. Then we will go for mesh and nodal analysis problems. Mesh and nodal analysis. We'll take the circuit diagram. This you can, this is second problem. You can, I'll give you notes. You can practice this one. Second problem. Second practice problem. Second practice problem. Right. Now we'll go for when two batteries are under operation. When two batteries are under operation. Operation means two batteries are on. What is meant by operation? Two batteries are on. When two batteries are on, current will flow. Current will flow. When two batteries are on, current will flow, bulb will glow. Voltages ఖచ్చితంగా ఆన్లో ఉండాలి. ఆన్లో ఉంటే కరెంట్ ఫ్లో అవుతుంది. Flow of electrons is known as current. Flow of electron is known as current will flow through the bulb and bulb will glow. Bulb will. Now 3 bulbs are glowing. when E1, E2 is on condition, batteries are on, bulbs are glowing. My question is, when running condition, operation condition, when bulb was glowing, what is the current through the bulbs? We have to find out with help of mesh and nodal analysis methods. I will give the problem. I will give the value of E1. I will give the value of E2. I will give the value of R1, R2, R3. I need the currents through the branches. Through the branches. What is how many branches for the given circuit? How many branches for the given circuit? 3. 1, 2, 3. 1, 2, 3. 3 branches for the given circuit. When 2 batteries are on, bulbs are glowing, I want current through the branches. For 10 marks question. For 10 marks question. I need the current through the branches. Can I say, give the names. Whatever the name we want to give, you give. Small I1. Can I say this is the branch? Can I say this is the branch? Yes, I1 is flowing. When 2 batteries are on. When 2 batteries are on, current is flowing. Current ఎక్కడ flow అవుతుంది? Branches flow. Now I want current. Can you tell me what is current here? I1. What is current here? I1. This is totally one branch. This is totally one branch. Now I want under operation, bulb 2 is glowing. I want current in bulb 2. Give the name, the new name called I2. Branch current. We call it as a branch current. I1 is a branch current. I2 is a branch current. Third branch, give the name I3. I1, I2, I3 are flowing through the branches under operation. Under, when 2 batteries are on, 3 bulbs are glowing, then I want current through the branches. The names are small I1, small I2, small I3. We have to find out the problem. How much current is flowing? How much current is flowing? When you know, if I know E1 value, E2 value, R1 value, R2 value, if I know all these values, then I will get I1, I2, I3. Then I will get I1, I2, I3 under operation, bulbs are glowing. What is the current to the bulbs? What is the bulbs? We need to find out. This is our target by doing some problems. So what method we need to get the values I1, I2, I3? నాకు ఏ మెథడ్స్ కావాలి? నాకు కనుక్కోవాలి. 2 బ్యాటరీస్ ఆన్లో ఉన్నాయి, 3 బల్బులు గ్లో అవుతున్నాయి. ఇప్పుడు నాకు కరెంట్ కనుక్కోవాలి. మల్టీమీటర్ నా దగ్గర ఉందనుకో, మల్టీమీటర్ ల్యాబ్లో ఉంటుంది, అది చెక్ చేస్తే తెలిసిపోతుంది. Multimeter we have in labs. Get the multimeter, check it out. You will get the answer. If you don't have multimeter, then you have to solve the problem. If you don't have multimeter, then what we have to do? Solve the problem with help of mesh and nodal analysis. Mesh and nodal analysis apply. I will tell you the procedure. Do the problem, you will get the answers. You will get the answers. I1, I2, I3. Clear all of you? What kind of methods we have to apply? To get small I1, small I2, small I3 branch currents. ఏ మెథడ్స్ అప్లై చేస్తారు? ఎనీవన్? మెష్ మెథడ్ అండ్ నోడల్ మెథడ్. 6th and 7th టాపిక్. 6th and 7th టాపిక్. మెష్ అండ్ నోడల్ మెథడ్ we have to apply to get the branch current. After getting the branch currents, please be seated. After getting the branch currents, I want voltage across the bulb. బల్బ్ ఎంత వోల్టేజ్ తీసుకుంది పని చేయడానికి? బల్బ్ ఎంత వోల్టేజ్ తీసుకుంది గ్లో కావడానికి? అది కనుక్కోవాలి. అదేంటి? ఆన్సర్ ఈస్ V1 across the bulb. V1 is equal to Ohm's law, I1 into R1. What is the formula? I1 into R1. ఇంత వోల్టేజ్ కావాలంటుంది బల్బ్ ఆపరేషన్లో. నాకు ఇంత వోల్టేజ్ ఇస్తే నేను గ్లో అవుతా. తీసుకో, ఎంత కావాలంటే తీసుకో సప్లై నుంచి. Who is the supply? Even E2. Who is the supply? Even E2. అక్కడి నుంచి తీసుకో, షేరింగ్ కరెక్ట్ చేసుకో. అది మన నెక్స్ట్ ఇంకో అడుగుతుంది, సెకండ్ బల్బ్ అడుగుతుంది. నాకు వోల్టేజ్ కావాలి, నాకు ఇంత పని కావడానికి. ఎస్, వాట్ ఇస్ ఆన్సర్? V2. వాట్ ఇస్ ఆన్సర్? V2 across the bulb. What is answer? I2 into R2. Ohm's law. We get the voltage across the bulb. Voltage across the bulb. Third bulb, what is answer? V3. What is answer? V3 across the bulb. V3 across the bulb. I3 into R3. I3 into R3. Yes, we got the voltage drops across the bulb under running condition. Under operation condition. What is operation or running? Two bulbs are on. Two bulbs are on, bulbs are going. This is the running condition, operation condition. Now I want I1, I2, I3. Branch, you should get branch current, then only we get voltage drops, V1, V2, V3. Without branch currents, you cannot get V1, V2, V3. Then after this is completed. Now third question is power consumption. How much power consumed by the R1 bulb 1? The formula is P1. Next one. Bulb 2 R2. What is the power consumed by the bulb 2 under running condition operation? Bulb is on. What is the power taken? Power consumed. What is the formula? P2. What is P2? Voltage into current. Voltage into V2 into I2. V2 into I2. Next, power consumed by the third bulb. What is the formula? P3. What is the answer? Voltage into current. V3 into I3. So this is the problem. My problem is that find the current through branches, find out I1, I2, I3, comma, voltage of across the resistors, V1, V2, V3, power taken by the all the resistors, P1, P2, P3 for the given network. 10 marks question. We have to find out. It's a simple problem. Practice. Go for practice. Now you got it? First we have to find out the branch currents. Then we'll get voltage drops. Then we'll get power consumed. Power consumed. Now units. What are the units for current? I1 amperes. Don't you have to write in amperes. After getting the answer, you have to write in amperes. What is the voltage drop? Volts. After getting the answer V1, what are the units? Volts. What is the power units? Watts. You have to remember this one. You have to remember this one. Current amperes. After getting the answer, 5 amperes. After getting the voltage, 2 volts. After getting the answer, 5 volt, 5 watts. Whatever the answer may be. Whatever the answer may be, this is the final target. I will give you a problem, you have to solve. I will give you a problem, we have to solve it. So what methods we are using here? Mesh method and nodal method. Get the branch currents. First what? Get branch current. Then automatically get voltage drops, power taken. Voltage drop, power taken. We have to apply two methods, mesh method and you can apply any one method, get the same answer for any given circuit. But practice. After getting practice, you decide which method you want. You decide by yourself which method you want. After practice, mesh analysis you do, nodal analysis, same problem. I will give three problems. One problem, mesh and nodal, same answers. Second problem, mesh and nodal, same answers. Third problem, mesh and nodal, same problems. Finally, you decide which method you want. For exam point of view. For exam point of view, take any one kind of method. Right. So, mesh method and nodal method. Now, how to get small I1? First, mesh method. First mesh method means loop. How many meshes are there? How many meshes are there? Two meshes. Two methods. Right. Our target to get small I1, small I3, small I2. This is our target for the given problem. Right. First mesh method. How many meshes are there for the given circuit? Two mesh. How many meshes? Two meshes. Mesh 1, mesh 2. Give the names capital I1, capital I2. This is called unknown currents. What is the name given to this one? Unknown currents are mesh currents. Unknown currents are mesh currents. First, we have to find out unknown currents are mesh current. We have some procedure. Apply the procedure. Get I1, I2. Next method heading. You can take clockwise. Now it is I1 is clockwise, I2 clockwise. Some other student may ask, we will take both anti-clockwise. Take your wish. Some other student will take one clockwise, one other is anti-clockwise. Some other student will take one is anti-clockwise, other is only four options. Both are clockwise. Both are one is clockwise, other is anti-clockwise. You take any kind of method, you'll get the answer I1. You'll get the answer. Once you get I1, I2, automatically you'll get the branch current small I1, small I2, small I3. Automatically you'll get small I1, small I2, small I3 branch current. Once you get a branch current, automatically you will get voltage drops, automatically you will get the power taken. Mesh method we have to apply. Mesh method we have to apply. What is the first one? Number of meshes. Mesh method heading. First one is number of meshes. How many meshes are there? Two. Condition. Both are clockwise. Both are anti-clockwise. Take any kind of clockwise. So apply the procedure. Apply the. Then we'll get the answer I1, I2. I will tell you the procedure later. By taking one problem. Taking one problem, you'll get I1, I2. Then automatically you'll get branch currents. Go for V2. Go for. Is it clear? Next. Mesh is completed. Mesh is I will tell you the procedure later. I will tell you the procedure how to get I1, I2. This is a procedure. This is a procedure. I will tell you later. First condition is take clockwise, anti-clockwise, whatever it may be, I1, I2, get the answer. Here, this is called mesh method. Now nodal method. Now extend nodal method. Same answer. We'll get the same answer. Now nodal method, the same answer we get. The nodal method, we have to go for the junctions. You have to go for the junctions, not loops. Don't go for mesh. Closed loop. Don't go for closed loop. We have to go for junctions. How many junctions for the given circuit? How many junctions? Two junctions. Two junctions. Two junctions for nodal method. Heading nodal method. You can apply mesh analysis. You can apply nodal method. Same problem. Mesh method is completed. Now nodal method. Nodal method, we have to take the junctions, not loops. Not loops. We have to take the junctions. How many junctions in the given circuit? Two. Out of two, the condition is one should be a reference node. The value of the reference node is 0. What is the value of the reference node? How many junctions are there? Two. Out of two, one should be a reference node. What is the value? 0. You can take top one or bottom one, your wish. You can take top one or bottom one, but most of the books bottom one. This make it reference node. The answer is 0 voltage. The answer is 0 voltage. First, we have to find out the junctions. Yes, two junctions. Heading nodal method. Heading nodal method. Find out number of junctions. Then one should be a reference node. How many nodes we get it? 5 means one should be a reference. 6 means one should be a reference node. 3 means one should be a reference node. One should be a reference node. Confirm. Second one, this one, give the name. For this one, give the name, your wish. A or B or C, whatever name you give. This is the junction. This is the, now this is unknown voltage. V1 we have to find out. We have some procedure. In mesh analysis, I1, I2. In mesh analysis, I1, I2. We have to find out. But nodal method, V1, unknown voltage. We call it as unknown voltage, we have to find out. We have some procedure. Find out V1. If you find out V1, automatically we get branch currents. If you find out unknown voltage, what will get? Branch currents. If we get branch currents, voltage drop. Voltage drop, power taken. This is the procedure of nodal method. I will tell you the procedure later. But thing is, if you apply nodal method, putting the heading nodal method, first condition is number of junctions. Number of, second one is, second is reference node. What is the value of reference node? 0. You can take top one or bottom one. You can take any one. But most of the books will take bottom one. We'll take bottom one. Not to confuse. We'll take the bottom one. The value is 0 voltage. Now remaining only 1 voltage, 1 junction. The remaining is, out of 2, only remaining is 1 junction. Give the name. What is the name given? A or 1, 2. Whatever the name you want to give, you give. A or 1 or 2. Then we have voltage. The unknown voltage we have to find out. We have some procedure, find out V1. Once we get a value of V1, then we'll get a branch currents. Then we'll get a, after that voltage drops. After that power T. These are the methods, 2 methods. Like this we have to solve the problem. Like this we have to solve the problem to get the branch currents. Final target is branch currents. Final target is, అది మన టార్గెటే అది. దానికి మెథడ్స్ ఉన్నాయి, మెష్ మెథడ్ అండ్ నోడల్ మెథడ్. ఆ ప్రొసీజర్ ఏంటో నేను చెప్తా. ఫస్ట్ కావాల్సింది ఏంటిది, అది ఏం చేయాలి సార్ అంటే, మెష్ మెథడ్ తీసుకోండి, హెడ్డింగ్ పెట్టండి, మెష్ మెథడ్ హెడ్డింగ్ పెట్టండి. ఫస్ట్ క్లాక్ వైజ్ ఆర్ డిసైడ్ చేసుకోండి, డిసైడ్ చేసుకోవాలి. తర్వాత మనం కనుక్కోవాలి. ఒక ప్రొసీజర్ ఉంటుంది, ఆ ప్రొసీజర్ అప్లై చేయండి. యూ గెట్ I1, I2, క్యాపిటల్ I1. ఆఫ్టర్ దట్ విల్ గెట్ బ్రాంచ్. అదే సార్ నాకు మెష్ మెథడ్ వద్దు సార్, నోడల్ మెథడ్ అప్లై చేసుకుంటా అంటే, సార్ అప్లై చేసుకో. నోడల్ మెథడ్ హెడ్డింగ్ ఫస్ట్ ఏం కనుక్కోవాలి, నంబర్ ఆఫ్ జంక్షన్స్ రాసేసుకో 2. దానిలో సెకండ్ కండిషన్ ఏంటి, రిఫరెన్స్ నోట్ తీసుకో, దాని వాల్యూ ఎంత 0. ఏదైనా తీసుకో, టాప్ ఆర్ బాటమ్. మళ్ళీ ఒక ప్రొసీజర్ ఉంటుంది, చేయండి. యూ గెట్ అన్నోన్ వోల్టేజ్ V1. ఒక్కసారి V1 వచ్చిందంటే ఆటోమేటిక్ యూ గెట్ బ్రాంచ్ కరెంట్స్. ఇవి 2 మెథడ్స్ ఉన్నాయి. అంటే మనం ఏంటి, మెష్ ఒక సర్క్యూట్ డయాగ్రామ్లో 2 కంటే కనిపిస్తాయి. ఒకటేమో క్లోజ్ లూప్ జంక్షన్స్. యూ టేక్ ఎనీ కైండ్ ఆఫ్ సర్క్యూట్ డయాగ్రామ్, యూ విల్ ఫైండ్ అవుట్ ఓన్లీ 2 థింగ్స్. వన్ ఈజ్ క్లోజ్ సర్క్యూట్స్. ఎన్ని ఉన్నాయో మీరు చెప్పాలి, ఎన్ని ఉన్నాయో మీరు చెప్పాలి. ఎన్ని క్లోజ్ సర్క్యూట్స్ ఉన్నాయి ఇక్కడ, ఎన్ని ఉన్నాయి క్లోజ్ సర్క్యూట్స్? 2. ఎన్ని క్లోజ్ సర్క్యూట్స్? 2 కాల్డ్ మెష్. ఇంకోటి మేకింగ్ కట్టింగ్ కోడ్ కనిపిస్తుంది, ఏంటిది? జంక్షన్స్. కట్టింగ్ కోడ్ కనిపించేది జంక్షన్స్. అంతే. ఏ డయాగ్రామ్ అని తీసుకోండి, మీకు కనిపించేది రెండు క్లోజ్ సర్క్యూట్స్ కనిపిస్తాయి, ఇంకోటి జంక్షన్స్ కనిపిస్తాయి. అవి మీరు ఫైండ్ అవుట్ చేయాలి. సర్క్యూట్ డయాగ్రామ్ని మీరు ఫైండ్ అవుట్ చేయాలి. ఎన్ని క్లోజ్ సర్క్యూట్స్ ఉన్నాయి సార్ అంటే 2. ఎన్ని జంక్షన్స్ ఉన్నాయి 2. అది మీరు ఫైండ్ అవుట్ చేయాలి. ఏ సర్క్యూట్ డయాగ్రామ్ తీసుకొని మూడోది లేదు, 2 ఉన్నాయి. క్లోజ్ సర్క్యూట్ జంక్షన్స్, క్లోజ్ సర్క్యూట్ జంక్షన్స్, క్లోజ్ సర్క్యూట్ జంక్షన్స్. సో ఈ ప్రాబ్లం చేయాలి అంటే నాకు ఒక నాలెడ్జ్ కావాలి. ఇవన్నీ చేయాలి, మెష్ అనాలిసిస్, నోడల్ అనాలిసిస్, అన్నోన్ కరెంట్స్, అన్నోన్ వోల్టేజెస్ ఇవన్నీ కనుక్కోవాలి అంటే నాకు కొంచెం నాలెడ్జ్ కావాలి. అదే నాలెడ్జ్ KCL, KVL. స్టేట్మెంట్స్ తెలియాలి. ఏం తెలియాలి? స్టేట్మెంట్స్ తెలిస్తే అప్పుడు వీ కెన్ డూ ద ప్రాబ్లమ్స్ ఆఫ్ మెష్ అండ్ నోడల్ అనాలిసిస్ టు గెట్ ద బ్రాంచ్ కరెంట్స్, టు గెట్ ద branch. So I will give 5 minutes rest, then we go for the next topic. Clear? 5 to 10 minutes. Clear? KCL KVL. Fifth topic. Ah, okay. Now we want to explain the KCL KVL so that we can apply mesh method and nodal method for any given circuit. For any given circuit. So first we should have the knowledge of KCL KVL to apply mesh method and nodal method. Otherwise we cannot apply mesh method and nodal method. We won't get branch currents. We won't get branch currents. That is the conclusion. Clear? What knowledge we should have? KCL KVL knowledge. Right. If you see the diagram, what we have observed very carefully, see the diagram, we observed that we identified that by seeing the diagram, we observe or identify that we have junctions and closed loops. Clear or not? You take any kind of circuit, we are identified or observed that we'll get junctions and closed loops. Closed loops is mesh. Closed loop means mesh without removing the element. You should not remove any element. You should not remove. Just observe the diagram. Just observe the diagram and tell me, you can identify very clearly that junctions are present and closed loops are present called mesh. You should not remove, just observe the diagram. So that if we get a junction, KCL we have to apply. If we get a closed loop, KVL should be applied. So what he says, take any kind of circuit diagram. For example, we can draw the circuit diagram for this room also. For this room also, we have fans, tube lights. Tube lights means resistive load, R loads. Fan means L loads. Whatever it may be, we can draw the circuit diagram for this room also. We will get closed loops and junctions for this room. For this room, you take any kind of circuits. Confirm. Take room, draw the diagram for these bulbs and tube lights. We can draw the diagram. We can find out there are junctions, there are closed loops. There are junctions and closed loops. So what he says, if we get a junctions, how many junctions we got? Two junctions. We got two junctions, confirm. Then KCL will enter. He says that if you get a junction, you have to satisfy his law. How many? What are the branch currents? How many branch currents are there? Small I1, small I1, small I2, small I3. Branch currents. He says that if you apply a junction at A, this is A, this is A, and this is B. We have to apply two times. We are applying KCL at applying applying KCL at junction A. And next one, applying. How many junctions you will get? You have to apply. If you get 6 junctions, apply 6 KCL. If you get 4 junctions, apply 4 times KCL. Applying KCL at junction B. B. You have to apply here, you have to apply here. KCL says like that. You can draw this diagram for this room also. If you get 5 junctions for this room, you have to apply 5 KCLs at this room, satisfy the condition. Then it is a valid circuit diagram. There is invalid circuit diagram, current does not flow properly, something will happen. It is invalid circuit diagram. Call it as invalid circuit diagram for this room, if I draw the diagram. So here we have to satisfy KCL after doing the problem. After solving the mesh analysis, node analysis, after solving the problem, we'll get the values. Small I1, small I2, small I. When we'll get the values? After solving mesh or nodal method. Unknown currents are unknown voltages. Unknown currents I1, I2, unknown voltage V1. If nodal method. If it is nodal method, V1. If mesh method, I1, I2. If you solve this problem, we'll get the values I1, I2, I3. At this junction, he says that, KCL says that, if you apply KCL at this junction, he says that the algebraic sum of currents, meeting at junction A should be 0. We have to satisfy it should be 0. It should be 0 for any kind of electrical circuit diagrams. If you get 5 junctions, apply 5 KCLs. If 10 junctions, apply 10 KCLs. Now how many junctions? 2 junctions. How many apply? 2 times. 2 times we are applying. When we apply, first we have to get the values of small I1, small I2, small I3. We have to get the values. Then I can prove it is 0. Otherwise I cannot prove it is 0. Right? The algebraic sum of currents. Without this one we cannot prove. I need one more thing. The first condition is clear. The algebraic sum of currents meeting at junction is clear. But without this sentence I cannot make 0. I need second condition also. The first condition is the algebraic sum of currents meeting at junction. This is the first condition. All should meet at particular point. All should meet at particular point. This is the condition 1. Condition 2, we have to know the sign convention also to prove 0. To prove 0 రావాలి అంటే రెండు కండిషన్స్ మైండ్లో పెట్టుకోవాలి. ఒకటేమో sentence. The algebraic sum of currents meeting at a junction. How many currents are meeting? Small I1, small I2, small I3. That's condition. Second condition, we should know the sign convention. It is plus I1, minus I1. Confirm చేయాలి. Plus I2, minus I2. Confirm చేయాలి. Plus I3, minus I3. Confirm చేయాలి. So I need the sign convention knowledge also. Condition 2. Condition 2. The first condition is sentence. The algebraic sum of currents meeting at a junction. How many currents are meeting? 3 currents. Confirm. Second condition is sign convention. So we go for the sign convention. Okay. See the sign convention. The first statement. See the statement. It says that the algebraic sum of currents meeting at a junction, a circuit is 0. It is a circuit. It is a circuit. 2 junctions are there. We'll apply. And we'll prove it 0. We'll prove it 0. Second, sign convention I did. Second condition. Second condition, I need sign convention to prove 0. To prove 0. So how to take? Toward the junction is taken as positive. Away from the junction is taken as negative. ఇలా తీసుకుంటాం. ఇలాగ రివర్స్ కూడా తీసుకోవచ్చు మీ ఇష్టం. ఫారెన్లో ఉల్టా తీసుకుంటారు. మనం ఇక్కడ ఇలా తీసుకుంటాం. అది డిపెండింగ్ అపాన్ ద సిచ్యువేషన్స్. బట్ అవర్ యాజ్ పర్ టెక్స్ట్ బుక్స్ వీ కెన్ టేక్ టువర్డ్ ద జంక్షన్ ఇస్ టేకెన్ యాజ్ పాజిటివ్, అవే ఫ్రమ్ ద జంక్షన్ ఇస్ టేకెన్ యాజ్ నెగిటివ్. వీ కెన్ టేక్ రివర్స్ ఆల్సో. తీసుకోవచ్చు, ఆన్సర్ వస్తుంది. నాట్ టు వరీ. ఎలానా తీసుకోవచ్చు, అది అజంప్షన్ ఓన్లీ. Toward the junction is taken as positive, away from the junction is taken as negative. In some textbook you will take foreign author books, toward the junction is taken as negative, away from the junction is taken as positive. Any take. But as for Indian books, we'll go for the first method only. First method only. What is the first method? Toward the junction is taken as positive, away from the junction is taken as negative. We follow this one only. Now apply the KCL at this junction. Toward the junction, what is the answer? I1 plus I1. Away from the junction, minus I2. Away from the junction, minus I3 is equal to 0. This is a statement given by the KCL scientist. He told that the algebraic sum of currents meeting at a junction in electrical circuit, it should be 0, confirm. He said you have to make 0. Then it is a valid circuit diagram. Then otherwise it is an invalid circuit diagram for this room also. If you draw the circuit diagram, if you draw the, it's confirm. He's a scientist. He got the Nobel Prize also. He has proved it. Now, how to get 0? First, we should know the branch currents. Small I1, small I2, small I3. We should know. Apply mesh method and nodal method. Get the answers. Apply mesh method and or nodal, any one method for the given circuit diagram. After getting the values of branch currents, you substitute in that one, definitely 100,000% will get 0. Then it is a valid circuit diagram. Then it is valid circuit diagram. First one is completed. Again it got doubt. We have second junction also. Again we have to prove there. Again we have to prove there. Then I'm making one more sentence. Applying KCL at junction B. Applying junction at B. Now tell me the answers. Tell me B. What is, how it is? How it is? Two words. Place I2. Can I say this is a branch current? Can I say this is I1? This is a branch current. I1 will flow. This is a branch current. I1 will flow. What is the answer? It is away from B. It is away from B. Minus I1. This one is coming toward the junction. It's coming toward the junction B. See this is a branch current. This is a branch current. Here to here is a branch. I3 will flow. I3 will flow. So it is toward the junction. What is the answer? Plus I3 is equal to 0. Apply the answers. I1, I2, I3, you will get 0. So if we get any number of junctions, we have to apply, we have to say it should be 0 after solving the problem. After solving the, then it is a valid circuit diagram. Otherwise it is invalid. The current are not sharing properly in the bulbs. The force is not sharing through the bulb. Right. After getting this one, so it's clear. And that's why statement. What is statement? It states that algebraic sum of currents meeting at a junction in a circuit, any given circuit is 0. Is 0. Right. Next one. To get the answer 0, sign convention must. To get the answer. I1, I2, I3 ఉంటే రావు answers. మీ చేతిలో I1, I2, I3 ఆన్సర్ చేతిలో ఉన్నాయి, మీ చేతిలో ఉన్నాయి. I1 is equal to 1 ampere, I2 is equal to 2 amperes, I3 is equal to 3 amperes, మీ చేతిలో ఉన్నాయి. ఆన్సర్ రాదు. Unless until you get the sign convention. Unless until, అందుకని algebraic అన్నాం. Algebraic అంటే క్లియర్ చేయాలా, ప్లస్ ఆర్ మైనస్. ప్లస్ ఆర్ మైనస్ క్లియర్ చేయాలా. That's why we'll get sign convention. Toward the junction is taken as positive, away from the junction is taken as negative as per Indian textbooks. Clear? Next one. How to explain, how to write the explanation. How to write the explanation. So in textbooks, as per textbooks, he won't give this resistance values R1, R2, R3. Instead of that one, you won't apply even E2 also for the explanation of KCL. For the explanation, this is a practical diagram. This is a practical diagram to get the, to prove KCL. To prove KCL. But it is not as per textbooks. Instead of bulbs, he will give only conductor, no resistance. It is a bulb. Bulb is having a conductor. Bulb is having a conductor. He won't mention R1. He won't mention R1 as per textbooks. This is R1. Only just conductor. Conductor is having a resistance. Practical case. We won't show symbol. Just it is a conductor. We have to, in our mind we have to think it is having a resistance. In our mind we have to think it is having a resistance without symbol. Next one, R3. Next one, R2. He won't apply any voltages. He won't apply any voltages. He won't mention resistance. He won't mention, just he will say junctions. Applying KCL at junction. You take you as per textbook, you take any direction. You take any kind of directions. Applying KCL at junction A to give the explanation. Get the answer. I1 plus I2 minus I3 is equal to 0. Finish. As per textbooks. As per textbook. Instead of 3 conductors, I will go 4 conductors extra. Already we have 3 conductors. My notes I have given 6 conductors. My notes how many conductors I have given? 6 conductors which does not have voltages, which does not have a resistance, which does not have a voltages, E1, E2, E3 ఉండవు సర్క్యూట్ డయాగ్రామ్లో, రెసిస్టెన్స్ సింబల్ ఉండదు, జస్ట్ కండక్టర్స్. ప్రాక్టికల్ కండక్టర్కి ఏముండాలి? రెసిస్టెన్స్ ఉండాలి. నేను చూపించట్లేదు. షో మీ ద నెక్స్ట్ స్లైడ్. Yes. 6 conductors I have taken here. It is theory part. It is not a practical problem. Just we have not applied the voltages. Voltages are there in your mind. Voltages are there in your mind. Resistance are there in your mind. Only conductors. How many conductors I have taken? 6 conductors. And the currents are flowing randomly. The current are flowing. You can take your wish. Some are away, some are towards. That is your wish. To give the explanation of KCL. To give the explanation of KCL, you have to take some conductors and make a junction and take some away. Then applying KCL at O. I1 towards the junction I1, I6 towards, I4 towards, I5 away, I3 away, I2. Like this, you have to give the explanation for the exam point of view. Example is రాయాలి మీరు. ఏం రాస్తారు మీరు? స్టేట్మెంట్ 4 మార్క్స్ ఇచ్చారు. ఎక్స్ప్లెయిన్ KCL 4 మార్క్స్. మీరు ఏం రాయాలి అప్పుడు? స్టేట్మెంట్ రాయాలి, సైన్ కన్వెన్షన్ రాయాలి, ఎక్స్ప్లెనేషన్ రాయాలి. ఎక్స్ప్లెనేషన్ ఎలా తీసుకుంటారు? 6 కండక్టర్స్ తీసుకోవాలి, ఒక జంక్షన్ పెట్టుకోవాలి, మీ కరెంట్ ఇష్టం వచ్చినట్టు తీసుకోండి. అప్లై KCL at O. Applying KCL at O. You will get 4 marks. You will get 4 marks. Right. Tell me the statement. Statement of KCL. The algebraic sum of currents meeting at junction is equal to 0. నెక్స్ట్ ఇంకేం రాస్తావు? తర్వాత స్టేట్మెంట్ రాసేస్తారు. ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూ ఇంకేం రాస్తావు? సైన్ కన్వెన్షన్. వాట్ వీ హ్యావ్ టు రైట్ డౌన్? సైన్ కన్వెన్షన్. వాట్ ఇస్ సైన్ కన్వెన్షన్? టువర్డ్ ద జంక్షన్ ఇస్ టేకెన్ యాజ్ పాజిటివ్, అవే ఫ్రమ్ ద జంక్షన్ ఇస్ టేకెన్ యాజ్ నెగిటివ్. అయిపోయింది. ఇంకా 4 మార్క్స్ రావు, 2 మార్కులే వస్తాయి. ఎక్స్ప్లెనేషన్ చేయాలి. ఏం చేసుకుంటారు? 6 కండక్టర్స్ తీసుకుంటారు. ఎన్ని కండక్టర్స్? అజంప్షన్ ఏంటి? రెసిస్టెన్స్ పెట్టకూడదు, వోల్టేజ్ ఇవ్వకూడదు, జస్ట్ కండక్టర్స్. అది ప్రాక్టికల్ డయాగ్రామ్. ఇది మా థియరీ. దాని కరెంట్ కూడా మీ ఇష్టం వచ్చినట్టు తీసుకుంటారు. కొన్ని ఏవే తీసుకుంటారు, కొన్ని టువర్డ్స్ తీసుకుంటారు. కూర్చో బీబీసీ కొన్ని ఏవే. దెన్ అప్లయింగ్ KCL at junction O. Applying KCL at junction O. Apply it, you'll get the answer. So in this way we have to write the exam point of view. Like this we have to write down statement, sign convention, explanation. So the KCL is completed. We have to prove KCL in practical diagrams. It should be 0. Practical diagrams it should be 0. It is a valid circuit diagram. It is a valid circuit diagram. So that KCL is completed. So that KCL is go for KVL. Next one KVL. KCL is clear? KCL is clear? ఏం చేస్తావు? 4 మార్క్స్ వస్తే నువ్వు ఏం చేస్తావు? యూ గెట్ 4 మార్క్స్ ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూ. ఏం రాస్తావు? ఫస్ట్ ఏం రాస్తావు? స్టేట్మెంట్, తర్వాత సైన్ కన్వెన్షన్, తర్వాత ఎక్స్ప్లెనేషన్. విల్ గెట్ 4 మార్క్స్. Right. If you observe the diagram, 2 things you identify. First one is junction. Yes, junction is completed with the help of KCL. If you see the diagram, you will observe 2 things. What are the 2 things? Junctions and closed circuits. Junctions and, yes, junction is completed with the help of KCL. It is a valid circuit diagram. It is a valid circuit diagram. Yes, current will flow, bulb will glow. Yes, exactly, it is taking the current correctly. Current correctగా తీసుకుంటుంది, బల్బు గ్లో కరెక్ట్ అవుతుంది. ఎస్, KCL సాటిస్ఫై. మరి ఇంకోటి ఐడెంటిఫై కూడా చేశారు మీరు. ఏంటది? క్లోజ్ లూప్. దాని గురించి డిస్కస్ చేయలేము మనం. జంక్షన్స్ గురించి డిస్కస్ చేసాము, KCL వచ్చాడు, ప్రాబ్లమ్ సాల్వ్ చేశాడు, అయిపోయింది. నౌ నెక్స్ట్ క్లోజ్ సర్క్యూట్ వస్తే KVL. ఇక్కడ కూడా సాటిస్ఫై చేయాలి మీరు. ఏం సాటిస్ఫై చేయాలి మరి? ఎస్, వీ హ్యావ్ టు సాటిస్ఫై దట్. We'll take simple, not we won't take this diagram, we'll take later. The first diagram, simple circuit diagram. Simple circuit diagram, only closed circuit, R1 5 ohms, assumption that R2 3 ohms and 10 volts is applied. Otherwise 5 volts, we'll take 5 volts, not to confuse. So ఇది సింపుల్ సర్క్యూట్ డయాగ్రామ్. 2 బల్బ్స్ ఇచ్చా, ఒక వోల్టేజ్ ఇచ్చా. 2 బల్బ్స్, ఒక వోల్టేజ్ ఇచ్చా. తర్వాత ఈ డయాగ్రామ్కి వెళ్దాం. విల్ గో నెక్స్ట్ డయాగ్రామ్, విల్ గో నెక్స్ట్ దిస్ డయాగ్రామ్. ఫస్ట్ విల్ ఎక్స్ప్లెయిన్ దిస్ వన్. ఇఫ్ యూ అండర్స్టాండ్ దిస్ వన్, ఆటోమేటిక్లీ అండర్స్టాండ్ దిస్ వన్. ఫస్ట్ వీ అప్లై వన్ మెష్, వన్ క్లోజ్ లూప్. దెన్ విల్ అప్లై కేవీఎల్. వాట్ ఈజ్ సేయింగ్, వాడు ఏం చెప్తున్నాడు, ఏం చెప్తున్నారు అక్కడ అని చూద్దాం. అది కూడా వ్యాలిడ్ కావాలి, ఈ రెండు వ్యాలిడ్ కావాలి. కేసీఎల్ వ్యాలిడ్ కావాలి, ఆల్రెడీ అయిపోయింది, ఇట్ ఇస్ కంప్లీటెడ్, ఇట్స్ వ్యాలిడ్ సర్క్యూట్ డయాగ్రామ్. కేవీఎల్ కూడా వ్యాలిడ్ కావాలి, కేవీఎల్ కూడా. ఈ రెండు వ్యాలిడ్ అయితేనే టోటల్ సర్క్యూట్ ఈజ్ వ్యాలిడ్, అదర్వైజ్ ఇట్ ఈస్ ఇన్వాలిడ్. క్లియర్? రైట్. వాట్ ఈస్ దిస్ కేవీఎల్? KVL says that one battery, 2 bulbs, bulb is on, battery is on, 2 bulbs are blowing, 2 bulbs, then find out the current I. Then find out the current I. So V is equal to I into R1, I into R1 plus I into R2. R2. So 10 is equal to, what is the answer? 5 plus I, 5 plus 5. 10 is equal to 10. What is the answer? 1. What is the answer got? 1 ampere. 1 ampere we got. I have taken a simple circuit, only one closed loop with help of one battery, 2 bulbs are connected. The bulb is having the resistance 5 ohms and 5 ohms. Now battery is on, current will flow. What is the value of current I? We have solved the problem. 10 is equal to drops. EMF is equal to drops. EMF ante volt battery. EMF ante battery. 10 is equal to drop. First drop. Current into resistance. First drop. Current into resistance. First drop. Current into resistance. Second drop. Across the bulb 2. Across the bulb 2. If you do the calculation part, the answer is 1 ampere. The answer is 1 ampere. Now substitute the value here. What is the voltage drop? V1. What is the V1 here? I into 5. Current into resistance gives you voltage V1. చెప్పనా లేదా ఇంతకు ముందు? V1 is equal to current into resistance, I1 into R1. VT is equal to I2 into R2. V3 is equal to I2 into R3. Same thing, V1 is equal to I into 5. What is 1? I. 1. 1 into 5. What is voltage drop taken? 5 volts. ఇక్కడ ఎంత వచ్చింది? 5 volts taken by first bulb. 5 volts taken by first bulb to do the useful work so that it will glow. It will glow. Next one, second bulb ఎంత తీసుకుంది గ్లో కావడానికి? 1 into 5. 1 into 5 again 5 volts. Again ఎంత? 5. 5. 10 నుంచి కరెక్ట్ షేరింగ్ చేసుకుందా లేదా? నేను 10, ఇది రెండు బల్బ్స్ ఉన్నాయి, బల్బ్ 1 బల్బ్ 2. నేను కరెంట్ కరెక్ట్గా డిస్ట్రిబ్యూట్ చేయాలి అని బల్బ్ గ్లో అయితే ఒకరికి ఏమో 5 ఇచ్చా, ఇంకొకరు 5 ఇచ్చా. 5 5 ఇది కూడా 10 కదా. అంటే ఒక లూప్లో ఒక ఇన్ఛార్జ్, నేను ఇది ఇన్ఛార్జ్, నా ఇన్ఛార్జ్ కరెక్ట్ డిస్ట్రిబ్యూషన్ చేయాలి. ఒక ఇన్ఛార్జ్ ఒక లూప్లో కరెక్ట్ డిస్ట్రిబ్యూషన్ చేయాలి, అప్పుడే ఇట్ ఈస్ అ వాల్యూడ్ సర్క్యూట్ డయాగ్రామ్. It is a valid circuit diagram. I am the in charge, battery 10 volts. These two are bulbs, bulb 1, bulb 2. We make a closed circuit. We made a closed circuit. So first bulb is taken 5 volts. Second bulb is taken. To do useful bulb will go. I need drop. In drop is not. How much drop he has taken? 5 volts. How much drop he has taken? 5 volts to take to complete the circuit. Solve చేయాలా. అందుకని మనం ఏమంటామంటే దీన్నే ఇప్పుడు దీని ఏమంటామంటే సమ్ ఆఫ్ ఈఎంఎఫ్. దీని బ్యాటరీ ఏంటి? సమ్ ఆఫ్ ఈఎంఎఫ్ ఈజ్ ఈక్వల్ టు సమ్ ఆఫ్ వోల్టేజ్ డ్రాప్స్. సమ్ ఆఫ్ వోల్టేజ్ డ్రాప్స్ అక్రాస్ ద ఎలిమెంట్. క్లియర్? ఇది కేవీఎల్ చెప్తారు. ఒక లూప్ తీసుకుంటే షేరింగ్ కరెక్ట్ ఉండాలి ఫ్రమ్ ది ఇన్ఛార్జ్, ఉండాలి ఖచ్చితంగా. దిస్ ద కాన్సెప్ట్ ఈజ్ సేయింగ్ దట్ ఇఫ్ యూ టేక్ ఎనీ కైండ్ ఆఫ్ మెష్, equal sharing should be there. You have to satisfy. It is invalid circuit diagram. Invalid. Any loops and running? Second problem, how many loops we got it? Second diagram, 2 loops. So first loop we have to apply KVL, satisfy. Second loop apply KVL, satisfy. Hence proved. Is invalid circuit. It is a valid circuit diagram. It is a valid circuit diagram. We have to prove that sharing is correct from the in charge. From the in charge. I am the in charge 2 bulbs. Sharing should be there. Voltage drops. Sharing అంటే ఏంటి ఇక్కడ voltage drop. డ్రాప్ అయిపోయింది పని చేసుకోవడానికి. ఎంత డ్రాప్ అయింది 5 volts. ఎంత డ్రాప్ అయింది సెకండ్ బల్బ్ 5 volts. Second bulb also 5 volts. We need to tell. Clear all of you? Right. So now tell me that. Now by seeing this diagram, tell me the statement. In a closed circuit, sum of EMF is equal to sum of voltage drop across the element. Sum of voltage drop across the element. This is the statement of KVL. This is the statement of KVL. కానీ మళ్ళీ ప్రాబ్లం వచ్చింది ఏంటి నాకు వాల్యూస్ తెలిసినాయి ఐ వాల్యూ తెలిసింది ఆర్ వాల్యూ తెలిసింది సప్లై బట్ సాటిస్ఫై లేను నాకు సైన్ కన్వెన్షన్ కావాలి అది +10 -10 నేను ఏదో +10 తీసుకున్నా మీకు అర్థం కావడానికి ఏదో +10 తీసుకున్నా మీకు అర్థం కావడానికి +10 అది +10 కావచ్చు -10 కావచ్చు అది +10 కావచ్చు -10 కావచ్చు అది కన్ఫర్మ్ చేయాలి అది ఒక ప్రాబ్లం తీసుకుంటే కన్ఫర్మ్ చేస్తా నాట్ నో కన్ఫ్యూజ్ అయిపోతాం విల్ బికమ్ కన్ఫ్యూజ్ ఐ విల్ టేక్ వన్ ప్రాబ్లం దెన్ విల్ టేక్ సైన్ కన్వెన్షన్ ఆఫ్ బ్యాటరీస్ sign convention of battery whether it is +10 or -10 we have to confirm we should know the knowledge which knowledge sign convention knowledge for the batteries adi go for KVL statement within 5 minutes we'll complete KVL statement right it states that listen very carefully last bench I'm going to ask you the question it states that what is the condition in a closed circuit it should be a closed circuit the algebraic sum of EMF means only batteries in that loop in that loop undali enni untandi E1 plus E2 plus E3 plus E4 or whatever it may be batteries undali sum of EMF is equal to algebraic sum of voltage drops I1 into R1 plus I into R2 plus I into R3 ఎన్ని ఉంటుంది అది సాటిస్ఫై చేయాలి దిస్ ద స్టేట్మెంట్ షేరింగ్ కరెక్ట్ ఉండాలి ఒక లూప్లో దట్ ఈస్ ఫైనల్ దానికి మనకి ఏంటి సైన్ కన్వెన్షన్ రావాలి ఏం రావాలి ఈ సైన్ కన్వెన్షన్ అర్థం కావాలి అంటే నేను ఎక్స్ప్లెనేషన్కి వెళ్ళాలి మీకు అర్థం కాదు చూపిస్తే మీకు అర్థం కాదు నేను చాలా ఎక్స్ప్లెనేషన్కి వెళ్తే మీకు అర్థమవుతుంది లేకపోతే అర్థం కాదు go for the explanation next one explanation take one diagram this is the diagram then you will understand the sign convention is it +E1 -E1 +E2 -E2 will understand by seeing this diagram for the batteries only clear sign convention for the sign convention only I have taken how many resistors I have taken 3 resistors how many resistors 4 resistors how many resistors I have taken 4 resistors R1 R2 R3 R4 how many batteries have we have taken 2 it is a one closed circuit apply KVL to mesh రైట్ ఇది సర్క్యూట్ ఇప్పుడు మనం అప్లయింగ్ KVL టు మెష్ అనాలి ఏమనాలి అప్లయింగ్ KVL టు మెష్ ఫస్ట్ థింగ్ ఏం చేయాలంటే యూ డిసైడ్ దట్ క్లాక్ వైజ్ ఆర్ యాంటీ క్లాక్ వైజ్ యువర్ విష్ ఏదైనా తీసుకోండి ఫస్ట్ అప్లై చేయాలి, స్టేట్మెంట్ అప్లై చేయాలి. ఐ వాంట్ టు అప్లై ద స్టేట్మెంట్. వాట్ ఇస్ ద స్టేట్మెంట్? ఇన్ ఏ క్లోజ్డ్ సర్క్యూట్ ద ఆల్జబ్రిక్ సమ్ ఆఫ్ ఈఎంఎఫ్ ఈజ్ ఈక్వల్ టు ద ఆల్జబ్రిక్ సమ్ ఆఫ్ వోల్టేజ్ డ్రాప్ అక్రాస్ ద ఎలిమెంట్. అది నేను స్టేట్మెంట్ రాయాలి. బై సీయింగ్ ద లూప్, బై సీయింగ్ ద loop we have to write on the statement, we have to write on the statement, right? The first condition, you have to assume that first clockwise or anti-clockwise decide cheskondi. Means clockwise or anti-clockwise. I will take clockwise, I will take clockwise. Here clockwise. Second thing, where you want to start, decide cheskondi. You want to start from R1, you want to start from R2 and make it a closed circuit, clockwise. So I will start where we have started. Yes, started from here, బ్యాటరీ అక్కడి నుంచి స్టార్ట్ చేస్తున్నా. క్లాక్ వైజ్లో చెప్పాలి. మీరు ఎందుకు మీరేమన్నారు? క్లాక్ వైజ్ అన్నారు. మీరేమన్నారు? అక్కడి నుంచి స్టార్ట్ చేస్తున్నా. సో ఫస్ట్ ఎలిమెంట్ ఎవరు? ఫస్ట్ ఎలిమెంట్. సెకండ్ ఎలిమెంట్, హూ ఇస్ ద సెకండ్ ఎలిమెంట్? R1. థర్డ్ ఎలిమెంట్ R2. ఫోర్త్ ఎలిమెంట్ E2. ఫిఫ్త్ ఎలిమెంట్ R3. R4. హూ ఇస్ ఎండింగ్? హూ ఇస్ ఎండింగ్? R4 is the ending. Now it is clockwise. Now it is clockwise. ఇది ఈ రెండు ఇది తెలియాలి. ఫస్ట్ తెలియాలి. ఫస్ట్ ఏమనుకుంటున్నావు? క్లాక్ వైజా యాంటీ క్లాక్ వైజా డిసైడ్ చేసుకో. డిసైడ్ చేసుకున్న తర్వాత నువ్వు ఎక్కడి నుంచి స్టార్ట్ చేస్తావో డిసైడ్ చేసుకో. E1 నుంచి స్టార్ట్ చేస్తావా, R1 నుంచి స్టార్ట్ చేస్తావా, R2 నుంచి స్టార్ట్ చేస్తావా, అది క్లాక్ వైజ్లో తిప్పండి. క్లాక్ వైజ్లో తిప్పాలి. ఇది ఉంటుంది. థర్డ్ థింగ్, లాస్ట్ వన్, వాట్ ఈస్ ద కరెంట్ త్రూ R1, R2, R3, R4 కావాలి. ద అజంప్షన్ ఈస్ కరెంట్ I. unknown current flow అవుతుంది. We don't know the value. Unknown current. What is current in this one? I. 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 ఇలా current flowing. All the bulbs. What is current in R1? I. What is current in R2? I. What is current in R3? I. What is current in R4? I. ఫస్ట్ కరెంట్ త్రూ ద రెసిస్టర్స్ తెలియాలి. ఈ మూడు తెలిసిన తర్వాతనే యూ హ్యావ్ టు అప్లై ద హెడింగ్ అప్లైయింగ్ KVL టు మెష్. దెన్ యూ విల్ సాటిస్ఫై ద స్టేట్మెంట్. దెన్ ఇట్ ఇస్ ఎ వ్యాలిడ్ సర్క్యూట్ డయాగ్రామ్. క్లియర్ ఆల్ ఆఫ్ యూ? చెప్పు ఏం చేస్తారు? ఫస్ట్ సర్క్యూట్ డయాగ్రామ్ చూడగానే ఏం చేస్తావు? ఫస్ట్ ఏం చేస్తారు? స్టేట్మెంట్ కాదు, ఫస్ట్ ఏం చేస్తారు? క్లాక్ వైజా యాంటీ క్లాక్ వైజా కన్ఫర్మ్. తర్వాత బ్యాటరీస్ ఉన్నాయి కాబట్టి నాకు క్లారిటీ తెలియాలి. ప్లస్ E1 మైనస్ E1, ప్లస్ E2 మైనస్ E2, అది కన్ఫ్యూజన్. దానికోసం ఏం చేస్తున్నా? ఐఎమ్ టేకింగ్ స్టార్టింగ్ ఎండింగ్. ఎక్కడి నుంచి స్టార్ట్ చేయండి, ఏ ఎలిమెంట్ నుంచి స్టార్ట్ చేయండి, క్లాక్ వైజ్లో తిప్పాలి. ఏది తిప్పాలి? క్లాక్ వైజ్లో తిప్పాలి. అది సెకండ్ కండిషన్. థర్డ్ కండిషన్, current through the bulbs. We will take clockwise, unknown current I. అది మనం ఫైండ్ అవుట్ చేయాలి, తర్వాత ఫైండ్ అవుట్ చేద్దాం. ఓకే, నౌ టెల్ మీ వాట్ ఈస్ కరెంట్ త్రూ R1? I. వాట్ ఈస్ కరెంట్ టు R2? I. వాట్ ఈస్ కరెంట్ త్రూ R3? I. వాట్ ఈస్ కరెంట్ టు R4? I. ఈ మూడు తెలిసిన తర్వాతనే యూ హ్యావ్ టు అప్లై హెడ్డింగ్ పెట్టాలి. ఏం హెడ్డింగ్ పెడతారు? అప్లైయింగ్ KVL టు మెష్. అంతవరకు మీరు హెడ్డింగ్ పెట్టకూడదు. applying KVL to mesh. అప్పుడు హెడ్డింగ్ పెట్టా. దెన్ యూ హ్యావ్ టు పుట్ ద హెడ్డింగ్ కాల్డ్ అప్లైయింగ్ KVL టు మెష్. నౌ టెల్ మీ ద సైన్ కన్వెన్షన్ స్టార్ట్స్ నౌ. లెఫ్ట్ సైడ్ ఏముండాలి? సమ్ ఆఫ్ EMF ఉండాలి. ఏముండాలి? ఆల్జిబ్రాయిక్ ఉండాలి. ప్లస్ E1 మైనస్ E1, ప్లస్ E2 మైనస్, దట్ ఇస్ కాల్డ్ ఆల్జిబ్రాయిక్. క్లియర్ చేయాలి. సో నౌ ఐ విల్ స్టార్టింగ్ ఫ్రమ్ హియర్. మైనస్ టు ప్లస్ ఇస్ కన్ఫర్మ్, ఇట్ ఈస్ E1, ప్లస్ E1. మైనస్ టు ప్లస్కి వెళ్తున్నా కాబట్టి ప్లస్ E1. అదే ఇప్పుడు బ్యాటరీ చేంజ్ చేసిన మైనస్ ప్లస్. వాట్ ఇస్ ఆన్సర్ నౌ? మైనస్ E1. నౌ ఇట్ ఈస్ ప్లస్ యాజ్ మై నోట్స్. ప్లస్ E1. నౌ సెకండ్ EMF. ఐఎమ్ కమింగ్ డౌన్వర్డ్స్. మైనస్ E2. దిస్ ఈస్ కాల్డ్ algebraic sum of EMF. One is algebraic means confirm the signs. Plus E1 minus, that is called algebraic sum of EMF. Left side is equal to algebraic sum of voltage drops. Now tell me what is the voltage drop here? V1. I into R1. Now tell me V2. I into R2. Now tell me V3, I into R3. Now tell me I into R4. If you know the values of E1, if you know the value of E2, if you know the value of 5, if you know the value of R2, R3, R4, R4, then we get 0. Both will be equal. 50 is equal to 50, 0. It is a valid circuit diagram. It is a valid circuit diagram. రెండు ఈక్వల్ కావాలి. The answer will be 0. షేరింగ్ కరెక్ట్ వెళ్ళింది, ఇద్దరు షేరింగ్ కరెక్ట్. నా దగ్గర నుంచి ఇద్దరు షేరింగ్ కరెక్ట్ వెళ్ళింది. 5 volts 5. 5 is equal 10 is equal to 5 plus 5 10. షేరింగ్ కరెక్ట్ వెళ్ళింది ఒక లూప్లో. అది మనం సాటిస్ఫై చేయాలి. క్లియర్? సో దట్ యూ హ్యావ్ కంప్లీటెడ్ కేవీఎల్. సో దట్ యూ హ్యావ్ కంప్లీటెడ్ కేవీఎల్. వాట్ ఇస్ స్టేట్మెంట్? ఎక్స్ప్లెనేషన్ ఏం చేయాలా? ఏదైనా ఒక లూప్ తీసుకోండి, మీ ఇష్టం వచ్చి లూప్ తీసుకోండి. ఎన్ని బ్యాటరీస్ అని పెట్టుకోండి, మీ ఇష్టం. ఎన్ని బ్యాటరీస్ అని పెట్టుకోండి, మీ ఇష్టం. ఎన్ని రెసిస్టెన్స్ పెట్టుకుంటారో మీ ఇష్టం. ఏదైనా పెట్టుకోండి, ఒక లూప్ తీసుకోవాలి. తీసుకొని మీ మూడు కండిషన్ సాటిస్ఫై చేయాలి. క్లాక్ వైజ్ ఆర్ యాంటీ క్లాక్ వైజ్, స్టార్టింగ్ ఎండింగ్. స్టార్టింగ్ ఎండింగ్ ఓన్లీ బ్యాటరీస్ కోసం, అది ప్లస్ ఇవన్నా మైనస్ ఇవన్నా కోసమే. తర్వాత థర్డ్ వన్ కరెంట్ టు ద రెసిస్టర్స్. కరెంట్ ఈ మూడు తెలిసిన తర్వాతనే యూ హ్యావ్ టు కీప్ ద హెడ్డింగ్ కాల్డ్ అప్లయింగ్ కేవీఎల్ టు మెష్. దెన్ సాటిస్ఫై ద స్టేట్మెంట్. Always sum of voltage is equal to satisfy. So that KVL is completed. ఈ నాలెడ్జ్ ఉంటే then we'll apply mesh and nodal analysis. Otherwise we cannot apply. Otherwise we cannot go for mesh and nodal analysis. ఎందుకు వెళ్తున్నాం? అన్నోన్ కరెంట్స్ కనుక్కోవాలి I1 I2 by using mesh analysis. అన్నోన్ వోల్టేజ్ కనుక్కోవాలి నోడల్ మెథడ్. అన్నోన్ వోల్టేజ్ అన్నోన్ కరెంట్స్ కనుక్కుంటే ఏమొస్తుంది మనకు? బ్రాంచ్ కరెంట్స్. మనకి ఏమొస్తాయి? బ్రాంచ్ కరెంట్. బ్రాంచ్ కరెంట్స్ వస్తే ఏమొస్తాయి? వోల్టేజ్ డ్రాప్స్, పవర్ కన్జ్యూమ్, ఇవి వస్తాయి మనకు. క్లియర్? సో దట్ కేసీఎల్ కేవీఎల్ ఇస్ కంప్లీటెడ్. సార్ స్లైడ్ 1 ఒకసారి చూసుకోండి, 1 minute. కేసీఎల్ చూసుకోండి అందరికి. ఓన్లీ 30 seconds టైం. ఓన్లీ 30 seconds టైం. ఐఎమ్ గోయింగ్ టు ఆస్క్ కేసీఎల్. వచ్చి డ్రా చేయాలి అక్కడ టేబుల్ పైన. డయాగ్రామ్ కింద కిందికి చేయండి, పైకన్నా పైకి. నెక్స్ట్ టాపిక్ రావాలి, డయాగ్రామ్ వస్తుంది. ఆపండి.